Our solar system is thought to have formed from a large cloud of gas. Such clouds are common in interstellar space. They are known as nebulae. Around 4.5 billion years ago, a dark cloud of gas contracted, and from it, the Sun and planets formed. As the cloud grew smaller, it began to rotate faster, and material moved towards the plane of rotation. Material that was shed as the cloud contracted would later make up the planets. At the center of the gas cloud, gravitational pressure raised the temperature to such a degree that nuclear reactions were started, and the Sun began to shine. It immediately sent out a powerful stream of material called the solar wind. The solar wind blew away much of the gas from the inner planets, leaving them small and rocky. The more distant planets were able to keep the large amounts of gas they'd accumulated and became giant planets. The Sun, a huge sphere of hydrogen and helium gas, is actually a star, like many others in the night sky. It only appears different because it's so much closer. It contains 99% of the mass of the solar system and produces enormous amounts of energy. In fact, it produces more energy in a second than humans have created in all their history. Where magnetic fields cross the Sun's surface, dark patches called sunspots are visible. These spots do actually give off light, but appear dark in contrast to the surrounding very bright areas. At the edge of the Sun's disk, huge flame-like eruptions are occasionally seen. These are known as solar prominences. This one rose to a height of 300,000 kilometers. Prominences like this produce a rain of hot gases onto the surface. When the Moon blocks out light from the Sun's disk, it's possible to see the Sun's outer atmosphere, or corona. The corona is constantly changing shape as the Sun's activity increases or declines. The closest planet to the Sun is Mercury. Mercury shows a striking resemblance to the Earth's moon. Mercury has no atmosphere, so it's a dead world whose surface has remained much the same for billions of years. Mercury bears the scars of impacts by thousands of small chunks of rock, known as meteorites. These impacts occurred mostly in the early years of the solar system, when meteorites were much more common. In contrast to Mercury, the second planet from the Sun, Venus, has a very thick atmosphere. Centuries of observations from the Earth have revealed little because the surface of Venus is always completely hidden by clouds. The greenhouse effect on Venus keeps the surface temperature at around 400 degrees Celsius with little variation from day to night. The next planet from the Sun is the one we're most familiar with, the Earth. Seen from space, clouds dominate the Earth, covering about half its surface at any one time. Visible below the clouds are the continents, oceans, and the polar ice caps. The Earth is the only planet in the solar system known to support life. The fourth planet from the Sun, Mars, is much smaller than the Earth and has only 1/10 of the Earth's mass. The distinctive red color is due to iron oxide in the soil. Mars has a much thinner atmosphere than Venus or the Earth, and clouds are not very common. Mars has 2 small moons. Both moons are believed to be asteroids that were captured by Mars several billion years ago. They probably came from the large belt of asteroids that lies between Mars and the next planet from the Sun, Jupiter. Jupiter is the first of the gaseous giant planets. In contrast to the inner planets, which are small, dense and rocky, the outer planets are huge spheres of gas without solid surfaces. Jupiter is the largest planet in the solar system, being more massive than all the other planets put together. The features of Jupiter's outer atmosphere are vivid and constantly changing. The most noticeable feature on Jupiter is the huge oval shape known as the Great Red Spot. This spot is an anticyclone or high-pressure system that's been visible from the Earth for over 300 years. Saturn is the second of the giant planets. Like Jupiter, it's a gaseous ball whose rapid rotation, once every 10 hours, makes it bulge at the equator. Saturn is best known for its spectacular ring system. It was once thought to be unique, but in recent years, ring systems of various sizes have been discovered around each of the other giant planets. Saturn's rings are thought to be made up of countless small chunks of rock and ice, up to 1 meter in diameter. These particles are so close to Saturn, they cannot combine to form into a moon. This is an artist's view of Voyager 2's encounter with Uranus. Notice that the rings of Uranus are smaller and fainter than those of Saturn. Also notice that its equator lies perpendicular to the plane of the solar system. Its rings and moons also orbit in this perpendicular plane. Neptune was expected to be very similar to Uranus. However, Voyager 2 discovered that it has an internal heat source that makes it emit more than twice the energy it receives from the Sun. This extra energy explains the appearance of Neptune's atmosphere, which has more detail than Uranus or even Saturn. An artist's impression of Pluto and its moon, Charon, shows the distant sun shining dimly in the background. Charon is quite large in relation to Pluto, being about half its size. Each is smaller than the Earth's moon. A number of other bodies make up the solar system, including comets and asteroids. Comets are thought to come from a large cloud of material lying well beyond the orbit of Pluto. Comets are thought to be made up of material left over from the formation of the solar system, and hence may hold clues about how the Sun and planets were formed. Astronomers may soon be able to land a space probe on the nucleus of a comet and take samples of the materials found there. In this way, they hope to discover more about the structure and history of our solar system.